Draft science type video. Yeah, this wasn't going to make one until I made another official video, but I was thinking I could also do that by, just putting, editing the video and putting words in the video. But some of the ideas of drawing pictures is good, so I have to think about that. So I guess I could always make the video and then I could draw pictures and put them in, but I don't know. It's almost like this is serious enough a conversation that, if you have to draw a picture, you're already in trouble, maybe. Kind of. But maybe not. I mean, pictures in physics do work. Illustrations. So anyway, just a whole page of stuff. Thinking lots of things. Today was very productive. Just in terms of trying to go through all these different parts of physics. You got the bent space, big space physics, and you have this migrates into this idea of velocity and time and acceleration, which is related to gravity because, yes, you accelerate in gravity. So this is the whole Einstein thing, like the equivalence principle. So you take bent space and you bend it into the equivalence principle, and that gets you into velocities in real space created by other things besides gravity. And what the consequence of velocity is. And that's where things got a little interesting in terms of my thinking. I mean, it goes both places. It goes into this stupid time dilation thing, which is just really a kind of cryogenics. But anyway, it bends into blue and red shift velocity, and it bends into current and charge and electric charge. Because when I was thinking about it, so the current I feel pretty good about. Description is that protons and electrons don't have the capacity to maintain momentum. They travel in vacuums, okay, but they're not going to travel in real space very far without crashing into something or losing their momentum. And I think you can sort of see that in the cloud chamber thing. Electrons always just kind of shoot out and then spiral into something and just kind of disappear. And that's sort of them winding down. They get accelerated and they lose their acceleration, and they lose it crooked, which is sort of what I was trying to explain to Hofladay. The spiral isn't because it's falling into a gravity with these little subatomic particles. So I better write this one down because I'll forget it. The spiral is a consequence of their deceleration. So I even as a kid remember seeing these things, and you see the little things shoot out and then you see it spiral, and it seemed pretty, wow, that's like gravity or something. It must be crashing into something. And it never occurred to me that it could be an automatic thing of its function, that perhaps it would have a imbalance, and it would slow down crooked. And how strong the evidence is in this sense is I haven't just I'm not saying this is the way it is on this one. Just because which I don't think you see is something that starts going spiraling one way, then goes straight again, then spirals the opposite way. But I really haven't looked at a bunch of cloud chamber images, so maybe there's one out there that does that. And they call it something. Of course they'll call it something. Give it a name unique to itself. But anyway, that's a side issue. So I probably shouldn't have wrote it down because, it's something I haven't thought enough about. But the idea that there is electrons just don't keep going. So matter holds velocity. So that's what I was thinking about today. So we're into charge, and then this gets into the basic ideas of a push-pull gravity. Push versus pull, and then wave versus particle. Wave of nothing versus a particle of something. and then square versus round geometry. And that's where it started getting very interesting in terms of what I was thinking, and you know, the visuals were really interesting. Because if you think about the arrangements being square, there's a subtle thing. It's not very subtle, and people are playing with it all the time. I guess I might play with some of it too, and try not to get electrocuted. But plasmas, you know, these light plasmas. And they have a real beam-like look to them. Okay, so the idea basically is to just run a spark in a vacuum or in a noble gas, and you get you know, dancing style light that does some interesting moving, not very fast, you know, and it's you know, it's obviously made of electrons. I guess what I'd say is just because it's moving like as if moving through a field, it's being manipulated by the charge in whatever vessel it's in, and you know, it's just quite interesting. And so I was thinking of that, and then thinking about the square geometry of electrons and protons possibly having, you know, the connection between the right turns, and the fact that you could capture force if it just kept making right turns. You know, 4 right turns, and you've got an orbit in a crude sense. And so I was thinking of that, and then you know, I started thinking about the proton, and it's producing the one color, you know, and then the electrons are producing their plasma, and but the real point is that I was thinking of it in the terms of that's sort of how it has to be, is that there has to be so much more of the field energy, the other ton stuff is much thicker, technically, than the matter. The matter is little tiny things. You've already heard this stuff. You know, the matter is little tiny stuff, and you know, there's a bunch of empty space in material things. You know, you hear all that crap, and but it's really not empty space. It's full of this plasma making material, potential plasma, if you want to call it that. And the only thing that makes it visible versus invisible is it does this polarizing thing. So if it's a certain polarization, we see it as force, and if it's not, we don't see it. You can look for a radio wave all you want, and you're never going to see one. Yet there's a ton of them, a lot more of them flying at you than probably the photons coming off your computer screen. They're bouncing all around you, radio waves, all kind of, you know, microwaves, all kind of stuff bouncing around you. You can't see any of it. So anyway, inside the so the point is that you know, let's think about clouds. So this is now connecting, you know, 3 or 4 different things, connected thoughts, and how they create lightning through movement. This rubbing thing. You know, the friction that creates, it's not friction, it's motion, and that creates charge that you're basically rubbing maybe electrons off and collecting them, so to speak. And to do that, it's through the mechanism of what you're also collecting is this force stuff. But anyway, the point I wanted to get to, the thing that was important from my perspective, was the fact that the matter is this thing, this pen, and if I move this pen, if I shoot it like a bullet, it's the same pen, but now what it has inside of it is a bunch of that force, and a bunch of that moving stuff between the electrons and the protons, the stuff that's balancing their positions, that's keeping the electrons where they are and keeping the protons where they are, and they're communicating with, let's say it that way, maybe these beams that are emanating you know, and doing this around and around thing. And that's what's happened inside a pen when it's moving really fast, is that it hasn't acquired mass, it's acquired force in between its electrons. But it hasn't really acquired it, is another key part here. It's acquired it in a polarized form, and it's the polarization that is the only thing that matters. So it's the electrons are polarized, the protons are polarized, and if the field energy gets polarized, then it's like a semi kind of matter. It now has given this the ability to impact something as if it was more matter, as if it was much heavier than it really is. It's no longer just this harmless little pin, you know, throw it at my head at, you know, 2 miles an hour, nothing. Throw it at my head at 20,000 miles an hour, something. And the difference is not that the matter's doing something different, it's that the force inside of it is now more polarized, which means it's more material-like, except it's not in the matter. Oh boy, I don't know if that sounded good. So what I'm saying is that in normal conditions it's a mixture. The color, it's blue and red, mixed up. But when you focus it to just being blue, or just being red, then it has the ability to substantially affect material things. It can interact with them now in a decisive, it can move through matter, and it can push matter, I suppose is one way to say it. It can move pattern. That's probably the way to say it. And the pattern is indistinguishable from the force. Maybe that's the way to say it. So if you thought about like a blue beam, a laser beam, and you put a blue electron in there, it's almost like you couldn't tell where the electron is, because it's all blue, if you get me. So it's as if the pattern has increased, even though the real material part of it hasn't. Just the force part of it. I probably lost you people with this one. Yeah, I haven't really drawn pictures extensively on this. I did draw something somewhere, I think. Yeah, it's not much of a picture, though. Yeah, it's just showing this going around as if this would be a representation of the motion inside the matter. So the real point is the little bits don't have momentum. But the interaction between you could almost say, the hub of the wheel and the electrons, and the idea of rolling through space does work, except it doesn't roll like a round wheel, it rolls like a square. So, anyway. Alright. So that gets me to the subject of electricity and the idea that the potential is acquired, and it gets back to magnetism again, too, just because it's so obviously dominated by this idea of polarization. So here's the idea of a magnet: is that the magnet is, whatever magnet you're seeing, it has little magnets inside of it. Okay, so that's one of the things in physics where it is just actually does that fractal kind of thing where it's like magnets all the way down. Obviously it's not all the way down, but the idea is you're just seeing a bunch of magnet, and you could cut it in half and you have 2 magnets, then you cut those in half and you got 2 magnets, and you do that going way down, because the whole thing is just a bunch of magnets stuck to each other essentially. And that regular matter is pretty much the same idea, except the magnets are arranged in different configurations, so they don't produce magnetism, they don't create the field effect, but they're held together by the same mechanism, little magnets. So the point is, if all the magnets are all lined up and all the magnets are same idea, you know, and you can cut them anywhere, and you're just creating two new ones of this, you know, of whatever mass they have. So what's the nature of it, though? Is that what's really happening is there is a current, and magnets are just happen to be, because they are built out of something that goes all the way down, they happen to do it extremely efficiently. So it seems like it's work or energy, but what's happening is just because of the configuration, you know, all of the stuff that's moving, that's going down the clothesline, everything that comes off of this assembly line of the top goes blue, let's say. Everything coming out of the bottom goes red. And the trick is in between those two, it has to do the inverse. So inside the magnet, it's actually having to do the exact opposite. That all the communication between one side of the magnet and the other is just reversing what they're producing. So to refill the well, so to speak. I mean, it can't keep producing blue unless it's getting a supply of blue. So say if the top of the magnet's blue and it's radiating this blue color energy, it's getting supplied from the red half that's pushing out a bunch of red. So you can sort of understand it in theory that red and blue goes in, mixed up. The magnet filters it into the two directions, essentially. That's the way to say it. I don't think it's the way I want to say it. It is filtered, and through the filtering process, the reciprocal, the equal but opposite reaction, you could almost say, is that inside the magnet there's a current. That's one side of the current's pushing all blue, the other side's pushing all red. That kind of thing. So it's like it could look, if you could see it, like an engine of some kind. Like this is like doing something. But what it's really doing is just taking things that are already moving, and the patterns are changing. And the pattern changing doesn't require any energy, as weird as that sounds. I mean, it requires merely communication. It really requires merely I have to come up with a better way to say cause. Alright, so that's the other catch to this thing, is that it is just a pattern of polarization. So you have to always keep, I've said it before, but I mean the rule sort of is that either you follow the arrows or you follow the polarization. But if you try to think of the polarization or the color as being some permanent element of the arrow, and then think about the arrows exchanging, you'll get it wrong, because that's not really what's happening. It's all really just a bunch of, you could just take them, you could take it as a grid work and just say there's beads at every single location. So you could just think of ropes going both ways, and where they intersect you put a bead there, and so these are all just locations. And what you're really doing is turning the beads a different color, flipping them, something like that. Or if you were to think of them as moving, they keep moving, okay, wherever they're going. All of them are moving, so you can never create one. You can never convert one. What you'll do is you'll take one that's going this way and change its color, and then change one going this way, change its color. But that's all you can do. There's no extra or less. There's just different patterns of color. Alright, that doesn't, I don't know if that says what I want to say, but you can sort of get the idea that you won't see something if it's all one color, you know, and that it becomes more visible if it's two colors mixed. How else to say that? You'll see you'll have more resolution. You'll see more of the bits rather than blobs. Alright, so I don't know if that's exactly how I wanted to go get to this. Yeah, sorry, my ability to articulate this as an, this is progress, but I'm not explaining. I don't think I'm getting where I wanted to go as well as I wanted to go to get there. But it's just because these subjects. So the point is too is that I was thinking about these other people who have competing theories. Okay, so the ether arguments and the electric universe arguments, and those became a little more something else I could explain why that's somewhat legitimate, in the sense that there seems to be a real connection between velocity and charge. So that one I think does make sense, in the sense that the idea of charge is a segregation of the polarization, and the segregation is what creates the traps, and the traps are what can roll okay, as a pattern, can roll on this bead matrix. Oh dear. Not that it has momentum, because it doesn't. See, every reaction, there's no way to really have momentum in the universe, because all the beads are moving the same speed. So every interaction is inevitable and at the speed of light. There's no lesser way to communicate. You can't do it quicker, and you can't, and all you're doing is interacting with pattern. So there's no real I don't know what the right word to say is, but that's the trick. The trick is that you're not moving the physical universe, you're just moving a pattern from here to here to here to here to here. And one way to think about moving that pattern is to say that the cause is one eye blink, and the effect happens while your eye is closed. Okay, so you see the cause, the effect, the cause, the effect. So if you didn't see the effect, you just saw it as a byproduct. When you go to your next cause, then maybe you could understand it. But it's kind of like that, in the sense that the mechanism that's moving the pattern let's see, no, the pattern's moving, not the mechanism. Right. And that the pattern can move in arbitrary ways. I could move this pen, let's say I was holding this pen. If I made a line of black right next to it, I would have moved the pen over this way, subtly, by just putting that line over there. Where the pen is now subject to negotiation, where the pen begins and where the pen ends. And you could almost say there's a 50-50 chance, once I add the extra black line, that the pen goes this way to the new black line, or it stays where it is and that black line goes away. But it's that kind of thing, where wherever the extra shows up, it's just redefining the pattern. And so you just get rid of something else eventually. So something shows up. And if you get rid of the other side, the other side that didn't show up on, then your pattern just moved. So I could move this pen just by making black lines, and it would just migrate by just changing those, by the pattern moving, not any of the elements of the pen actually moving. I'm adding stuff going this way, and the pen's moving that way, if you get my drift. That sort of makes it illustratable, that it's not so much the momentum of the pattern or the momentum of the stuff. It's just the circumstance of what has pattern, and where pattern is moving, and where it's heading. If pattern is heading for you, it's going to be a real event when this much pattern shows up at my forehead, let's say. And if the pattern happens to be very decisively regenerating a new front. So that's what I mean by the rolling. So if it's rolling towards me, so to speak, and that it keeps making a new black line in front of it, yeah, then it's heading right for me. The pen's moving. But that's the idea, is that's what velocity is you carry enough polarization to keep creating pattern in front of you. You just keep throwing the pattern in front of you, and you just keep stepping on the stone you put in front of you, and you pick up the stone behind you and put it in front of you. It's like kind of like that. It's like you end up walking on a bridge you're making and tearing up at the same time. Yeah, so yeah, I know I'll have to explain that one, but it's actually possible when there's no when you recognize that there's no bits that are actually moving faster than any other bits, and it's just the pattern that's moving. Alright, well anyway, I didn't want this to be a pattern video because I've done them in the past. What else did I want to say though? Yeah, so that's this catch with velocity. Velocity is a so what I guess I really wanted to get to was if a pattern's moving, there's a lot. This is like really, it's like that plasma kind of thing. These are protons, electrons that are pushing lots of force between them. They're plasma-ing a lot of force between them. And that's the effect that causes the time dilation. And that could be more illustratable with that kind of, once I diagram the motion of that force, the polarization. Again, this force is always there, it's just that it's random force versus polarized force, segregated by color. See, again, it just sounds like you're moving the arrows and you're just moving the color. See, so it's really hard. I got to find better vernacular for this. And the whole point is this whole idea of color is just a way of two-dimensionalizing something that just might be about the 3 dimensions. It just might be that they're not on the same dimensional plane. So when I'm saying polarization, I'm really just saying something that's not oriented. It doesn't have an ability to communicate because it's not on the same plane. It can only communicate in one point. I probably should work on that model just in case that is the truth. Because if that's the truth, then yeah, maybe the color thing, well, you'd still have to use the color thing to be able to distinguish between this and this in a visual model. But anyway, it is interesting. Alright, so I did the charge thing, motion, this creates polarization, segregates it, and yeah, it's just, I really want to get just to the idea of so I mean the Einstein thing of the bent space. So you could say something like, okay, they should just dump it because it just doesn't make any sense. It's the biggest force, the most obvious force in the universe, gravity. It's moving the same speed as all the other forces. So does it make any sense for me to say bent space moves at the speed of light or the speed of force, more specifically? Now that would just sound kind of stupid. Bent space moves at the speed of magnetism and light. I mean, it just seems like you ought to just concede that bent space must be one of these forces. That's why it moves at the same speed. And then you have the push thing. I mean, it's just so obvious that push is the simple force. Because the model of bent space is a convergence. It's pulling, it's stretching space. However, it's like a conveyor belt, all going in. And it's just, that is just such an extraordinary mechanism. Going in and there's no exit. Where the external force is one you can imagine rebounding off of something external and bouncing back in. It's a lot harder to imagine something internal that can somehow push the force back out to the outside so you can reuse it again. That's a little hard to do. The reflection inside of a bubble is a lot easier to imagine than the idea of something going into a vortex and then somehow coming out evenly on all the sides. Just doesn't make much sense. So the idea that it's space and that it's not a thing, it just seems so obvious. I seem so, why cling to bent space? And then part of the reason they'll cling to it is because, well, this gives them this convenient way to bend time. Okay, so that's really probably the only reason why they have to cling to it, is because now they've done this bending of time, and if you got rid of bent space, just having bent time wouldn't make any sense. Then they know they'd be in trouble. So you can't really leave, you can't really let go of bent space unless you let go of bent time. And then that gets rid of all of their, the fun physics of imagining all their multiverses and their traveling through the universe and light speed and warp drives and all of that bullshit. But it just seems like it's doomed. And even the idea of time dilation is such a wrong way to say it, right? We're stuck with their rhetoric, but it's not really that time dilates, it's just that time's retarded. But you can't dilate it in the opposite direction. You can only dilate it in the sense that you can only make clocks run slower. They won't run faster. They'll run faster relative to you. That means you'll find something quieter than you, and its clock will appear to be running faster. Let's see. Yeah. So I guess that's the thing to find is a location where isotopes decay much faster. But yeah, where the radioactive decay takes place much faster. I have to think about that one. Sorry. As a way of testing what time it is. Different locations. Which always have to have some other clock to compare it to. That's the catch. But time is the vehicle that you get into velocity with, because time is what we use. Light is, the speed of light is what we use as the constant by which we calculate velocity, because velocity is basically distance in a certain unit of time, and the only way we have a unit of time is through the speed of light as a constant unit of time. So I guess we need, if we could find some other constant by which to measure time besides the speed of force, well, it wouldn't matter because that's a constant, so it's always going to give you the same answers. It's always going to be there as a constant whether you like it or not. Well, anyway, so I didn't want to get into that. But yeah, there was a little stupid little Puro comment. He made some kind of point about something. It was just stupid. He mocked my bouncing in gravity kind of metaphor, where I pointed out that the reason why the GPS clock imbalance exists is because we're actually moving faster here on Earth. Our clocks are actually going slower, and so they have to adjust the clocks on the satellites to go slower because they're going too fast, and our clocks are going slower because we're actually moving faster than the satellites. So Piro's argument is because, it's because of gravity. And no, that's the tiny percentage of, so one of Einstein's theories, is the acceleration special. And one of them is the velocity general. And it's the general theory where, the velocity theory, where all the big time dilation takes place. and the special theory acceleration is tiny by comparison. And so the point is for you to find why we are doing time dilation, we have to find a much higher velocity than merely the acceleration component. The 9 meters per second wouldn't be enough velocity in the general theory to create any significant time dilation. And so what really has to happen is that it's the 9 meters this way and then the 9 meters a second back, and that it's this distance, the up and down part of that, that is our real traveled distance. And that's what gives us the higher velocity, is the fact that we're actually covering more distance, where the satellite in the weaker gravity isn't in as much of an an extra, it's not doing as much bouncing. It really does matter. I mean, it's like a basketball bouncing across a basketball court. If you add up its real velocity, it isn't like how far it's going across the court. It's really about how much distance it travels going up and down. Alright. And you know, you have to count the up as well as the down. They're all distances the basketball travels in a certain amount of time, and that's its real velocity. Alright. Okay, I didn't really want to go there. So anyway, this wasn't... I mean, it's good. It's probably good I made the video and I don't like it, just because that'll make it clear that I really do have to do this. I just want to try to... It's so hard to isolate them as just 3 or 4 subjects, but that's all there really are. So there's bent space, and then there's time dilation, which is really the effects of velocity and acceleration. And then that becomes an argument too about the 3 dimensions, because I'm going to make the argument that your velocity is just a conversion of the substance of you into a force moving in one direction. And that's the catch to it, though. It's the last bit of your force would be the electrons and the protons themselves, because the real part of the force, the real part of your mass, the substance of it is that plasma moving between the field energy between the electron and the proton is just as real, materially, so to speak, as the matter part. And that's what I wasn't accounting for. We see empty space, but it's not empty. So when you're counting something as being a volume, what counts is all the forces inside of the pen. The pen isn't just the electrons and the protons, it's every one of the quanta or photon or magneton or graviton or whatever you want to call that force. All the bent space, whatever stupid, all the wave stuff, wave energy. I shouldn't use their, I mean, I'm mocking it, of course, but I mean, I'm just saying, whatever you want to call it. The point is that's part of the pen. The pen isn't just the material bits, it's the forces holding the material bits together. Alright, so, but the idea, alright, so that's where the fish metaphor begins to fail, because you have to identify what part of the school of fish is going to be the electron and what part is the field energy. Because there's places where you're not going to be able to tell the difference, except for by behavior. The electrons are bending the flow of the plasma, and alright, so that I have to figure out a way to point that out. It's like they're the conduits. They're like they're almost like interferometers. The electrons are like mirrors. They take the stuff in over here and they shoot it out over there because somebody else is pushing it into them in the back, and so it's all the equal and opposite reactions they're imposing on each other. Yeah, that's sort of understandable. I mean, if I make a square box, if I just make a square with 4 people and I just say, okay, you push him in the back, and then you push him in the side. You know, your side pushes him in the back, and then his side, he pushes the other guy, and that pushes him in the back. What, you know what I mean? You just end up pushing all the way around, and so your equal but opposite reaction just comes up from behind you eventually and hits you again. So whatever action you do here ends up coming right back and hitting you in the, yeah, that kind of thing. Alright, well, anyway, this just didn't, but anyway, so the point is, so yes, you go to bent space, you go to warped time, then you go to this whole dimensional crap, which is really dangerous, and then, oh yeah, then you get into Heisenberg, which is, again, just related to the condition of things. You know, they think they have real randomness, like, there's this Heisenberg moment or something, you know, and all of a sudden, the universe rolls real dice. You know what I mean? Real randomized dice. You know, not the fake random that we have in our real material world, but some kind of real random happens. You know, just silly. But anyway. Yeah, and then that, you know, that bends into the relationship between electrons and photons, the ones we see, and then electrons and the more obvious electrical functions, like you know, electric charge and magnetism. You know, so it all, so that's the physics. It's like that group of subject, and it just seems kind of obvious, in my opinion. It seems kind of, it's seeming kind of obvious, okay, to me. The elements that are wrong. The pull versus push, the wave versus the particle, the idea that forces don't affect forces. Just, you know, they don't. So light isn't getting bent by anything. It has to hit something to change its direction. And what else? Well, anyway, I'll get to it, whatever the other else is. So, so it is just kind of funny. I'm not thrilled with how well I explained. You know, today was really a good day, and I just really didn't explain how, yeah, it does make sense. I just didn't make it make sense. So, my bad. I'll work on it.